Welcome to Cpp.chat, an undoable look at what's going on in the world of C++, chatting with guests from the community. But before we debug this week's episode, John has a disclaimer to read.
Thank you very much, Phil. Our disclaimer this week is redistribution and use in source and binary forms with or without modification are permitted, providing that the following conditions are met. 1, redistributions of source code must retain the above copyright notice, this list of conditions in the following disclaimer. 2, redistributions in binary form must reproduce the above copyright notice, this list of conditions, and the following disclaimer in the documentation or other materials provided with the distribution. This software is provided by Cpp.chat as is, and any express or implied warranties, including but not limited to the implied warranties of merchantability and fitness for a particular purpose, are disclaimed.
You're not supposed to shout some of that.
All righty. So it's great to have you joining us, Greg. Is this your first time on?
Yeah, it is. My first, very first time.
That's great. That's great.
I think you have been on that other show, though, haven't you?
What other show?
What other show?
A good answer. CPP, our friends.
Our friends CPPcast, who do a marvelous job, and we. There's plenty of room. There's plenty of room, and glad to have you do their show as well as to do our show. It's great. So I want to say, well, first of all, for those who aren't familiar with you, you're the CTO and co-founder of Undo.io. Is that just the URL, or is that the actual name of the company now?
Yeah. We tend to say undo.io if we're just speaking about it. Yeah.
It's the brand.
You're almost on brand. Yeah.
All right. Okay. And the name Undo, of course, comes from the fact that what you've done is made a reverse watch point or reverse debugging, adding it to GDB, which seems silly because GDB already has reverse debugging, right? So what's the point?
Right. And it has had for some time. I mean, the point is to do this in a scalable way, right? So I mean, just to kind of recap on what we're trying to do here. So the undo or the ability to go backwards is really it's the ability to go back to any instruction that executed in your program's history and see any piece of state, right? Any location of memory, any register, right?
Right. So in other words, instead of setting a watch point and saying, let me know when this changes, I can have a situation where I said, wait a minute, when did that go bad?
Exactly.
And I can set a watch point in the past and back up to where it changed.
Exactly right. And so that's, which is, if you think about it, what you want, right? If you stop for a moment to think about debugging, it's really a whole exercise in like, how did that happen, right? And
where did this go wrong?
Where did it go wrong, right? The program has done something that was different from my expectations. And so where in the program execution did reality diverge from my expectations? That's really what debugging is, right? And so, for decades, the tools helped us to go forwards through time, which is just the opposite of what you need. But the reason is it's hard, right? And it's hard to do it in a way that scales. If you think about that, if you just think doing it in the naive way, every memory location, every register change for all of history being recorded very quickly, it's just going to be billions of operations every second. That's going to get huge, and it's going to go very, very slowly. And that's what the native GDB implementation does. It records just the delta of every instruction, right? But that's your 16 bytes or whatever for every instruction that executes, and that adds up very quickly, and it goes enormously slower. So the recent generation of tools of which Undo is one. There's also RR, which originally came out of Mozilla. There's also the time travel debugging stuff from Microsoft, and these later generations of tools use a different approach to trying to build this in a way that scales and in a way that doesn't slow your program down by, in the GDB case, thousands of times, right? And doesn't consume huge amounts of memory, and so it's very fiddly to get that right. But when you get it right, you can we record big applications like SAP HANA, for example, right? Big database, millions of lines of code, terabytes of memory, EDA tools and Cisco routers and other big applications, and that's where the real value is, right? Because these are the things that are really, really hard to debug. Hello world is usually quite easy to debug when it And yeah, so what, that's what these latest generation of tools do, is to allow it to work, at scale on real world big applications.
So how do you do that?
So how you do that is essentially relying on this sort of observation that computers are deterministic things, right? If you run a program multiple times, every time you run it, you have the same starting state, and you feed it the same set of inputs, then it will always do the same thing. This is why random numbers are difficult to generate, right? So if I want to go back a little bit, maybe a second, go back up a second or something, rather than trying to unpick my state, I go back to the beginning or a snapshot in between and play that forward to the point where I want to be, right? And that's much more efficient in terms of you need to record much less state. The catch is computers are completely deterministic except when they're not, right? And so what you need to do is to capture all of that non-determinism. I mean, it might be a read from the network or get time of day or anything like that. You capture all of that non-determinism on the record mode on the reference run as you go through, and then when you replay, you only need to reconstruct those non-deterministic events. Right. And the point is, those non-deterministic events are a tiny, even for a very I/O heavy program, are going to be a tiny fraction of what the program is mostly doing, which is pushing and popping to the stack and adding these two numbers together and that kind of stuff, which is all deterministic. Right. So you just re-execute to recompute previous states.
But even some things that are technically deterministic, like reading a file, you can't know from the beginning of the program that it's the exact same file. So you have to treat reading the file as if it's completely non-deterministic, even though in practice it really is.
Yeah. So I mean, actually, we have a mode you can switch where you can guarantee that this file is immutable and it's always going to be there and it's not going to change, to kind of optimize that. But in the general case, yeah, you say I mean, if you think about it, any system call that you make that your program makes, if you could recompute the value of that system call from the internal program state, then it probably shouldn't be a system call, right? It would be a library operation. But if you can't, it kind of needs to be a system call. And so all of those system calls, we intercept and we'll record the non-deterministic results of those calls, and file reads, is one example. And it's not just that the file may no longer be there. You might be trying to debug your recording on a different machine, right? And so the file might never have been there, and so that's fine. We capture all those and the same, for memory mapping and all the kind of complexities that the real applications do. So it's making it work on the real world. I remember when we just set out, I was advised by a professor at the university here. We're in Cambridge in England, and he said basically it's impossible non-determinism, and I kind of have great pride that look, we were right, and we've showed that it wasn't impossible, we could do it, or we've done the impossible. But you know what? Actually, he was almost right. I mean, it is really tricky to get. Because it has to be down to every bit has to be precise, right? If you get even a slight deviation, some small piece of non-determinism that you don't quite capture, then it goes wrong in ways that, and unfortunately and ironically, are themselves very difficult to debug, right? Because you've got what makes bugs difficult is there's a couple of axes here, right? But there's one is the length of time between the actual bug and you noticing the seg fault or the assertion failure or whatever it is, like the longer the elapsed time, the more stuff's gone, the more water has flowed under the bridge, and the harder that is. Then the other axis is kind of how deterministic is it, right? Does it fail in the same way every time, or does it just fail, one every 1,000 runs, or in a different way each time it fails? And if you sort of plot that on a graph, right, on these two axes, and you get kind of in the top right hand corner, it's a long time between the problem and you noticing and it failing in a different way every time. Those are the things that are borderline impossible to debug, right? And we have cases of customers using this approach to using our technology to debug things literally in hours that they'd been trying to fix for, like in some cases, literally years. We had one was 5 years. 5 years but now obviously that's not like full-time developers working on that for 5 years trying to fix it.
But they were aware of the bug for 5 years and couldn't crack it.
And it was a high profile, tried lots of repeated attempts to try to get to the bottom of it. They could reproduce it under load and under kind of load testing, after like a day or two's execution or something. But they just, they couldn't crack it, right? Because it was, extreme on those two,
Right.
on those two axes, and it's multiple occurrences of things existing for months or years and just being fixed.
And of course, one of the problems with that axis is you don't know. In other words, you don't know how much water has gone on. You don't know how long it's been because you don't know where the bug is.
Absolutely.
So it may be that you just have a really rare occurrence, and then when it happens, you almost immediately fail.
Yep.
But if you don't know that,
exactly, you don't know, right? And the only upper bound is how long has your program been running for, right?
That's right.
Other than that, it could be a nanosecond ago, or it could be right at the beginning. So yeah.
Right. Yeah. Okay. So we have a question in the chat room that says, "Are you aware of any work being done on LLDB support for reverse debugging?"
I don't, not that I'm aware of. I mean, I should say that technically our stuff is it's actually a sort of a layer, a process, recording layer that GDB is the most commonly used interface onto. But there are other kind of debugger interfaces onto it that you can use. The total view debugger from now Perforce is one of them. Actually, I don't think this is going to be relevant to any of the listeners here, but the Visual COBOL debugger from Microfocus is one, and that's a kind of interesting case. I know this is about C++, but which like that there's still a lot of COBOL out there, right? And the thing is, most of the people who wrote that COBOL are either retired, they're retired either from work or from life, right?
Or both.
Yeah, right. Well, I mean, I guess one implies the other, doesn't it? But yeah, and so, and you've got, but these, all the banks in the world and everything else kind of built on this stuff,
right?
And so that turns out to be a really so it's actually really useful for understanding code. Not just really, it's about code comprehension. It's understanding what did the code really do, right? Mm-hmm. And most of the time that means debugging, but actually it can also just mean like, how does this even work, right?
Right.
So yeah, so it's not, so it in a sense, it ought to be pretty straightforward to onto the undo engine, or onto one of the other implementations of this approach. As far as I'm aware, there's no work being done to do that. The most use of LLDB that I see, anyway, is because it's inside the Mac, the Apple tools, right? And some other kind of GUI things use it. And now the thing to understand, though, is just plugging it into LLDB wouldn't mean that this suddenly works on Mac. Because if you think about what we said earlier, what we're doing is to intercept, among other things. I mean, there's thread switches and signals and non-deterministic instructions and a whole bunch of stuff. But the big one is system calls.
System calls.
We're intercepting all those system calls, and they're different on different different kernels.
Yeah.
So porting it to getting it to work on Mac would be, I mean, it's doable, right? I mean, it is a Unix architecture system, so it would be a mere matter of programming. But it's not something that we've done, and I'm not aware of anybody else having done that yet.
Mm-hmm. Mm-hmm. Apple has lots of resources. It wouldn't surprise me that they might.
Yeah, I mean,
might try to do something like that.
Right, absolutely. I mean, Microsoft have, right, and on for the Windows platform. Which, was launched at CPPCon last year, wasn't it? Or was it the year before? But
they announced time travel.
Yeah.
Just talking about debugging generally, this is one of the things that I remember in my travels as a contractor. I often was in a situation where I had to come up to speed on a new code base as quickly as possible. And I did meet someone who said that's how they did it, was they set a break in the debugger and they just watched it run. Step through it and kind of, because when you have all this code and some high percentage of it is exceptional cases, not necessarily error handling, but just, there's this kind of, whereas if you just say, okay, I'm going to run this program, this is what I'm going to do, and you follow that path through, you hit all the common code very quickly and you get a better understanding.
Yeah, I mean, I'm not wanting to turn too much into a kind of advertisement or something, but the reversible capability is even more useful there, because when you're inside, I mean, most large applications, whatever, many millions of lines of code sometimes, and you get lost very easily. You step through and suddenly it's like, oh, hang on, I knew where I was. I kind of had at least a partial construction of the work, sort of situational awareness, if you like, of what my program was doing. And now I've just like followed some function pointer or stepped into something and now I'm more lost, right? And the ability just to undo, right? But the ability just to go back to where you previously were is actually really, really helpful, because you kind of, you essentially what you're doing in that, when you're in that mode, is you're learning some big code base that's like millions of lines of code or whatever. You're depaging the knowledge into your head of that code base, right? You can't just sit at line 1 of file a.cpp and read the whole thing through. You're demand paging as you go, and yeah, when you very easily get off the beaten tracks. The ability just to sort of, I'm going to mix my metaphors, but pop back up the stack and just go back, but not literally pop up the stack, right? Just go back to where I was, follow that, just go back to where I was a second ago is, yeah, we've all been there, right? You continue and, you hit a breakpoint you weren't expecting to hit. And then, suddenly you're like, well, hang on, I've got no idea where I am, how I got here. Yeah, I've got a cool stack, so maybe I can see a little bit, but often it's just, I'm completely in the boondocks here.
Or you may have taken a path where you said, okay, I'm not sure what's going on here. And then you get into it a little bit and you see, oh, it's just going to check this and it's going to spend a bunch of time. No, I want to get back to the main path. This is just a little thing that it does periodically, which I think I understand. And I don't want to spend any more time looking at that code.
Yeah. And now you can, traditional debuggers will let you do that pretty well, of course, because you can finish out of the function, right?
Set a break,
or what GDP calls finish, and I think most debuggers have this. You can just say, I'm just going to just continue until this function, until the stack frame pops and this function comes back. So that's, and that's really useful in that. In that
but if what you wanted to do was to go back to before the call to change something in memory so that it won't take that path and takes the other path, that's what is harder to do. Because you've already passed that if, whether you're in the if or the then, either way, you've passed it. And what you want to do is you want to go back and say, I didn't mean to take this path. Let's change the code so that, or not the code, but the memory, so they go down this path.
No, and although that's something that you can't do with any of the reversible approaches and implementations that exist today, because you get to go back in history and change an event in history, right? Because that kind of leads to paradoxes.
I see.
So you get I mean, let's say your program really did unlink a file from the file system, right? Remove that file, and then you go back and say, actually, I'm going to change that path so that I don't unlink the file. Well, it's that's like gone now from the outside world, right? So so there are sort of challenges with that. I mean, you could do it, and in principle, it could be done within certain confines. We do allow you to change state when you're in what we call record mode. So when you're in that sort of live point of the execution, you can change the state, and that becomes a non-deterministic event that goes into our event log so that it can be replayed. But we kind of it's funny though. It's one of the first questions almost always asked when I talk to this, talk to somebody about this for the first time, because you're kind of giving somebody a time machine, right? And you give somebody a time machine, and the first thing they always ask is, well, can we go back and kill Hitler? Right. That's always that's what you would do if you had a time machine, right?
Yeah.
So the answer always is no. You can just go back in time but you're an observer. It's a time machine, but you're an observer in that in the past.
So you couldn't go back in time and kill a parent process.
Exactly. You can't do that, right? Because that's it. The grandfather.
I hadn't even thought about that, but you're absolutely right when you pointed out. You've actually divorced from the real world when you start to replay these non-deterministic.
You're just kind of looking at a video. I sometimes describe it as like, so with the regular debugger, what you're doing is stopping time, and this technique that was pioneered by the Matrix, I think, of like the thing would stop and the camera would like pan around the screen, and it would say like time is frozen, and now you're looking all around from 360 degrees, and then everybody started to do that for a few years, and that's kind of what a regular debugger lets you do, right? Lets you stop the program and lets you go around and see everything 360 degree, any angle you can go and look at any piece of state or anything, and then with the undo stuff, or with any kind of time travel or reversible debugging, what you're doing is that, but you can also wind the time back, but you're still kind of an observer, right?
Mm-hmm.
But it's funny. People always ask that question when they're first exposed to this stuff. Can I go back in history and change things? And a little, usually a little bit disappointed to learn that, no, sorry, we can't do that. But it stops becoming a question very quickly because people realize actually you don't need to really with this stuff, because the reason you're changing history, you actually like to change things often the reason you'll change things in a regular debugger is because you're kind of doing that what if exploration, right? You're saying, well, yeah, I think the problem might be I'm calling this, function when I shouldn't, or whatever it is. So I'm going to change that, that global so that I call the fallback on or something and see if the problem goes away. Well, you don't have to do that what if exploration when you've got reversible debugging, because you can just go and see, right? So you don't have to have hypotheses that you test anymore. You just go and
well, yeah, particularly if the reason you're tracking this is because we've got the crash right here.
Yeah.
There's no what ifs. We know that this is the path that leads to the crash.
Exactly what happens.
So there's
so it's tell me, and that's what it's for, right? It's just tell me what just happened, rather than me trying to get little tiny pieces of information, little clues, and in some kind of Sherlock Holmes brilliant kind of deduction, figure out, aha, this must have happened, then this, know. So I have had people complain that it takes all the fun out of debugging.
Okay, people who have fun debugging. All right.
I've got some projects they can work on.
Yeah, that's right. A lot of fun for you guys. Actually, though, talking about the fun of debugging, one of the things that Kate Gregory talked about, which was kind of, I hadn't really thought about it, but she was talking about teaching beginners, and one of the problems you have in teaching C++, particularly at the beginning, is there's no small subset that you can just say, okay, we're just going to look at this. You're constantly, without meaning to, pulling in all this stuff. And if you actually, when you talk about Hello World, you kind of say, oh, there's this pound include stuff at the top. Just ignore all that. We're only going to talk about this part now. And we'll get back to the other part, And so one of the issues was, well, do you want to show them printf, which is maybe not what we want to do. We prefer to show them streams, but streams are just complicated enough that printf might be a more expeditious. And what Kate says is, don't do any IO at all. Do them a favor. If you want to know what the value of X is, tell them to go in the debugger. You're teaching them something that's valuable right now, and you're sidestepping the whole output stuff. You just say, okay, now go into your debugger and tell me what the value of X is at this point.
I think it's, debuggers are, any debugger. They're such a powerful teaching aid, and they're really not used in most of the education that I've seen. It's in fact, this is pertinent to me because right now my wife recently quit her job as a physical therapist and has signed up to Lambda School and is learning to be a programmer, right? And it's all JavaScript, and I'm already, she's like 6 weeks in, and I'm already well out of the place where the zone where I can be of any help. But and they don't do any debugger stuff, right? It's all console.log and all this stuff.
Yeah.
And and it's just and she's somebody who's coming in to programming afresh, right? And she, her mind hasn't yet been like twisted and warped in the way that our minds have been over the years. Yes. So she's off. Yeah, right. It's happening, but so things like a return statement in the middle of a for loop, right? And you're sort of trying to explain, oh, well, no, you see, because you're going to come out too early. Hard to explain that stuff. Step through in a debugger, and you can just say, oh yeah, of course, I can see what's happening. Right. So you're not in that, yes, it's okay. It's kind of using the debugger in that example to debug something, but it just as an education tool, and just to say, look, when I have this particular code construct, this is what it does. Is, I think, so I completely agree with Kate. Underutilized. Well,
I kind of understand why, because if what you're trying to do is teach programming, then one of the things you could say is, well, how could we modify the program to find out what that value is, or how could we figure out what's going on? Now, it's terrible from a productivity point of view, because that's the last thing you want to do is, I'm just going to rewrite my program in order to find out. No. You want to use the debugger as a tool. But if your job is to teach people how to use the language, using the language to solve the problem doesn't seem like a terrible solution. It is bad in the sense that you're not teaching people the productive way to be programmers, but you can see how an instructor would fall into that trap.
But I think it is a trap, right? Because it is. And it comes back to what I was saying before, right? That actually the what's called a debugger, it's a misnomer. It's a code comprehension tool, right? And just that, 99% of the time when we're trying to understand what the hell the code really does is because we're debugging, but not always. And when you're a beginner, or in any way when you're learning something, you're in that code comprehension, mode, right? And maybe you're just looking at some, new C++ construct that you haven't seen before, and like, how does that actually work? Well, let's have a kind of hello world equivalent for that and step it through with the debugger. There's no bug. I'm not debugging it. I just want to see what it's doing.
Yeah.
I like your invocation of the matrix bullet time.
Yeah.
Well, you said that's what the debugger is like, but actually that's what a breakpoint is like.
Yes.
When you're stepping, you're actually moving usually forwards in time,
right?
At your own pace. But now with undo and others like it, you can go backwards as well. So it's that ability to have complete control over time.
Yes, exactly.
It's really useful.
Yeah. It's complete control over time, and just see what happened rather than trying to deduce what must have happened.
Yeah. So I do want to talk a little bit about the talk that you gave at CPPCon. And I like, by the way, that you're really introducing people to tools, and that's kind of what your talk was about. Your talk wasn't really about reversible debugging, although you talked a little bit about that. Yeah. But the more thing was learning the tools and talking about what tools are available. And I there's a sense in which this isn't really a C++ talk, but it's clearly anybody who's doing any real programming, certainly any systems programming, has to do all this stuff. I mean, it's part of what your toolkit has to be. It just so happens that these particular tools, not particularly language specific. So how did the talk go? And tell me about why you wanted to do this one. And
yeah, it was a lot of fun. Always enjoy doing a talk at CPPCon, which I've done now for the last 4. I mean, I think I didn't talk at the very first one, but I think I've done a talk at every one since. And it's become sort of a little bit of a mission, if you like. But that I think for the most part, programmers. And I think I've got to say, I think C++ programmers are particularly bad here. Don't invest the time in learning tools, right? It can be there's lots of really good free tools that are available. There's the commercial tools like ours. I mean, Coverity, who where I was presenting with DeWang from Coverity from Synopsys SIG, which is the kind of company that does Coverity, yeah, I mean, I think developers as a whole don't really invest enough time in learning and understanding these things that can just the ROI on the return on investment in time of understanding some of these tools is huge, but I think I have a sort of bit of a developed a little bit of a sort of hypothesis on this of why it seems to be particularly bad in the C++ world. And it's because if you're attracted to that kind of low-level systems programming, right, it's like C++ is a language that's unashamedly close to the metal, right? And so most C++ programmers have chosen to be C++ programmers rather than JavaScript or Python or something, right? I know a lot of people do multiple languages, but if you're specializing in that, it's because there's something about that you like, right? And there's lots of good stuff about C++, but the thing that really differentiates it from any of the other languages, with the exception of C, is that is how close you are to the metal, and it kind of attracts and develops a kind of culture of roll your own, do it yourself, and I know that's changing now with more and more libraries and things available. So I think hopefully what I'm describing is a thing from the last 10 years rather than the next 10 years, right? But I think it does culturally, it has a kind of culture of do things from scratch, from the ground up, and that includes kind of debugging. And I mean, Coverity, whether you'd call that a debugger or not, and perf tools might be not sort of debugging as much as, but if it's it's anything about just tools to just be better at your job, right, and be a better programmer. And the right tool used in the right way can save huge amounts of time. I mean, I gave the examples of years turning into hours, but those are kind of the extreme cases, of course. But very common, you'll spend a week looking into some issue. It might be a performance issue, it might not be a correctness issue, but whatever it is,
Mhm.
You know, and there's a very rich ecosystem of tooling available now, and that's really changed over the last 10 years as well. Yeah, I just see so many programmers, you know, doing the old printf debugging, or, you know, whatever it is from scratch, and it's just such a waste of time.
Mhm.
So yeah, I'm trying to get it out. And in a lot of my talks, what I try to do is, they're not workshops. I'm not trying to, you know, the intention is not anybody leaves the talk with being an expert in one of these tools, but they know it exists. They probably knew it exists anyway, but now they can see a little bit what it can do. A lot of times, actually, as well, these things are surprisingly easy to use. Like, people assume things like ftrace or perf or valgrind or coverity, or these are going to be, you know, complicated, hard to use things. I'm going to waste. I think that's part of it as well. I'm going to waste days of my time kind of coming up to speed with this thing when, you know, my boss is screaming at me to get it fixed like yesterday, and so it's going to, you know, I know I can do it quickly. But actually, then they can see that, oh no, it's not that hard. It's not scary anymore because the mystery is gone. So maybe now, next time I need that, I'm going to, you know, just, you know,
building up some motivation for this.
Yeah, and I'm going to go.
We actually
page or whatever. I'm not going to know what to do off the bat, but I'm not scared of it in the same way.
We actually did have a workshop on C++ tools, or well, I guess it was specifically Linux tools or Unix tools. I'm not sure. I think it was Linux. Yeah. So for people who did want to get into how do we set these things up and all that kind of stuff, we had that as a 2-day class.
Okay, I didn't know that, but I mean, and that's great, and that's you know, that's obviously the next level. You know, you really are coming back as a, you know, you leave the conference and you come back as actually an expert in this stuff. But if you've got the time to, you know, put into that, I think that's definitely the next level. But, you know, for people who only have, you know, perhaps an hour to watch the video on YouTube, or, you know, they want to just, you know, they've got a lot of different talks they want to attend at the conference and they want to come in, then, you know, it's just showing what's there and showing people, you know, not to be afraid of this stuff.
Right. And some tools, you know, are things that you can build into your build system. So that was what Dwang from Coverity was able to talk about, these static analyzer tools. And so you joined forces with him, because I think what you told me was you felt like he could do a better job of talking about those tools, but they were so important you didn't want to leave them out of your talk. So
exactly. I put in the abstract, you know, that we'll cover Coverity, and I knew that the Coverity would be interesting to people, right? Because it's got a good reputation, and it is quite mysterious. Most people haven't kind of seen it. And then I thought, right, okay, well, I better go and learn this stuff then. If I'm going to talk about how this stuff works, the best thing I've got to do is go and learn it. They do say the best way to learn something is to teach it. I think that's totally true. But then, so I actually got in touch with Dwang but somebody else I know at Coverity, and said, hey, I'm gonna do this talk in a month's time, and I thought I better learn the stuff. And so I got put in touch with Dwang, and I was just gonna get him to teach me. So can you give me a demo and, you know, point me at some stuff, and then I explained about, you know, the conference and what was going on, and he was like, well, why don't I just come and join you? And I was like, yeah, okay, let's do that. And, you know, I can be lazy and just learn by sitting in the audience.
Yeah. Well, you know, you say it's lazy, but I say it's getting an even better talk, because the total presentation was better because the expert was doing the part that he was the expert on. No, that's great. Absolutely. And I got a chance to talk to him at the conference. I'm very much hoping that, well, of course, I'd love to have Synopsys be a sponsor. That would be wonderful. But also to be an exhibitor and to have a chance to, you know, present at tool time and those kinds of things. But I'd love to have him come and do a full session. Because clearly you could easily spend an hour. You could spend probably 4 hours very easily talking about all the different kinds of things you can do. Because one of the things it can do is kind of out of the box. You can say, you know, find me things that you can find with static analysis. I mean, the problem with static analysis is you don't actually know all the paths, and so you have to kind of assume all the paths, and so that's there's some things you can't really do as well at static time. But if you can do it at static time, that's brilliant, because you don't have to build test cases, you don't have to do all these kinds of things. You can just have it say there is a path that goes from here to here without ever releasing the memory or without ever initializing the value, or, and when you see that path, then you can sit there and say, yeah, I can see how that.
Right. It's like the way I sometimes describe it is Coverity and other static tools are answering the question, could this happen?
Right.
Whereas the dynamic tools are answering the question, did this happen?
Right.
And and I always say, things like Coverity, if you can find the issues, before your code is released and before the customers do and before the bad guys do,
right.
Then that's totally valuable, right? And hugely valuable. And again, the time you can save, and the cost you can save, in preventing these kind of incidents happening in the first place is significant. And I think it's the combination of the two. I noticed that basically all of our customers are also customers of Coverity. Well, except after Coverity got acquired by Synopsys, then Synopsys's main competitors switched away to using other tools. But all of our customers are customers of Coverity or one of the other static tools. And that's and I think it's so we absolutely know the first often we get compared to Coverity and people assume that we're a competitor to them, but actually it's totally complementary, because it's like, what could happen? Let's fix those issues before it gets bad, versus what we do is let's deal with the thing that's hurting you right now. Right. And deal with that pain right now. So it's like prevention and cure. And
this is one of the things that he got into in his talk, and I thought he did a great job of presenting, because it was a surprise to me several years ago when I was kind of investigating static analyzers. One of the things I learned was you don't want to hear all the problems with your code. And it's because so many of them are potential problems that you will spend a lot of time to analyze something and then realize, yeah, theoretically it could happen, but in the real world, it's just never going to happen. I don't have to worry about that. And I would have thought, well, yeah, there'd be some of those cases, but if you're writing really good code, you want to plug those holes too. And it's like, no, there's just a ton of wasted time. And so he actually said, unless you're a security researcher, unless you're looking for someone who's deliberately trying to put you in a state that the real world would never see, then you don't want to see all those. And you only want to see about 1 in 20. And that really surprised me. But he said, we want to find the 5% of the issues that we find, those are the ones you worry about. And but the other thing that was kind of cool about Coverity, which is different than I think, well, maybe not all, but many of the static analyzers, is the way you can customize it to your own situation. So if you have a library and you say, look, every time someone makes this call, later they have to make this call, because this call is going to put you in a state, and you got to make this call to come out of the state. And with Coverity, you can actually set that up and say, is there a path for someone making this call where they don't later make this call? And that wouldn't be that hard to set up. It's designed to do those kinds of things. Is there a path that comes from here and doesn't go to here? Warn me about that.
Increment the reference. I've got to decrement the reference before I,
something like that.
Give the function, that kind of thing. Yeah.
Right.
Yeah. That's actually how it grew. I remember I was handed the paper that came. It was some researchers at Stanford in like very early 2000s, 2001, I think it would have been, and they were doing it against the Linux kernel, which then would have been like, I don't know, 2.2 or something, and they found a whole bunch of issues of, exactly that, right? Of you've got to drop this lock before you return, or you've got to, obviously C++ makes some of this stuff easier, and you can have a constructor, release the resources and you can have a bit more confidence. But, there's still an awful lot of ways, you can get in trouble. And so that was, and they found, I can't remember how many hundreds, but hundreds of like real bugs like this in the Linux kernel. And, I emailed I think it's Dawson Engler, the person running the project at Stanford, and said, hey, this looks really good. This would be great for a project I'm working on. Could I get a copy of the code? He didn't respond. And then 6 months later, they launched the company. And I was like, oh. But they had an interesting thing that because the early versions at least were built on GCC. and quite deeply. So if they'd released that as a product, they would have they would have to release it under GPL, right?
Yeah.
So actually, they had an early business model where they would go around. Somebody would turn up with a laptop or whatever, and that they wouldn't distribute the code. They would turn up and check your code, for you and give you the answers. And then later on, they used the what's the front end, the Edison Design Group C++ front end to do the parsing, so that they could kind of actually ship it as a product without having to give it all away, open source. But, yeah.
Right. But and this is one of the things that I was thinking about is you can put this in your build tool, so you make your change and it just automatically checks it overnight and comes back and says, these are the new instances, and you can look at them. And of course, because this is the common thing, when you look at this and you say, no, it's not a problem, you can actually turn that off. You can say, you can add a comment to your, well, you don't actually add it to the code, you add it to the Coverity tool and say, when you see this problem at this location in this code, so you don't even have to modify your code to do this. You just say, don't tell me about this again. I've investigated. I'm okay with it.
Right. And by the way, I think that's for all of these tools, integration into the continuous integration is the key. Is the key thing, right? And so and that's what many of our customers do as well, is they integrate Live Recorder, which is the kind of offline recording tool that we have into the CI, and so that when you get a failing test in your CI. Normally, Jenkins or whatever, you'll get, you'll get some artifacts, you'll get a log file. If you're lucky, you'll get a core file, that kind of thing. It's like, well, now you spit out a recording as well.
Right.
And so particularly for those intermittent failures, intermittent and long run failures, it's very, very convenient. You don't have to worry about now reproducing it. It's just there and getting.
Not only do I not have to reproduce it, I don't even have to have a machine that it could be reproduced on.
Absolutely.
It's just a recording.
Yeah.
So I can just debug into the recording, and I don't need a machine that is set up to handle whatever, if there's special hardware involved or whatever. I don't need that. Exactly. I don't need a special file system. I don't need any of the other stuff. Yep. All I need to do is be able to look at the recording and step through it and figure out.
Yeah. And it comes in, and what we found actually, we've done some started to do some research on this, and we've been polling people on. Actually, we did some of the questioning at Cpp.chat on of the issues that you get back from production, the production failures. How many of those can you trace back, either indirectly or directly, to a failing test, right? And the it's kind of early days, and the sample sizes aren't huge still, but we're coming back to like somewhere around 20 to 30% of production failures or outages or bug reports can be traced back directly or indirectly to some test that was failing, right? And I think we've all been there, right? We've all been there's something that fails, you can't figure it out. It's very rare. We kind of turn it off or find some way to mask the failure. And then, sometime later, sometime later, everyone has to spend all weekend, with everything on fire, diagnosing this critical problem. And then somebody says, oh yeah, actually we did have a test for that was failing, but we turned it off. And so it's being able to much more quickly, properly get to the bottom of these intermittent failures is really important. So it's related to your point on Coverity, right? That you've got all these things that could happen. What you really want to know, and then you've got from the things that could happen, you've got the things that you really, the subset, which is the things that will happen, right? Mm-hmm. And if you're seeing it in test, even if it's only, one failure in a bazillion, that is a thing that will happen. Mm-hmm. And if you're going in production at any kind of scale, it's going to happen, probably lots of times. So
that's right. If something's a 1 in a million chance of happening, that means it's only going to happen once a second, right?
Yeah, exactly.
Your production is really a distributed test system.
Yeah. Well, that's what testing in production is becoming quite. I mean, it depends what your code is, right? But it's becoming
customers. It's not the customer's favorite way of testing, but
no, you've got to be. Yeah. I did hear from somebody actually that. Poor old people in New Zealand must have a very different view of the internet, because they get both everything gets kind of A/B tests kind of rolled out, and because partly because it seemed to be it's a relatively small population, but representative of the populations that the companies do care about, which is the North America and Europe. But also they're first as the world spins, right? They're the once it was New Year's first in New Zealand, right? So if something goes live on a particular date, then the Kiwis get it first. and it's a bit like there's a joke that's said here in the UK sometimes that the Queen must think the world smells of fresh paint. Everywhere she goes, it's just been painted, and it's probably your experience of the internet as a Kiwi is probably the opposite of that.
Right. Yes, it's. Well, I do notice that so sometimes, I'm on the Amazon program for new books that come out, and I'm curious about this, and I look at the reviews, and the early reviews, the ones that are, it's like, how could you have done this? And it's, well, I got it as soon as available, and I've read it, and here's the review, and they're from New Zealand, because that's the first people who can get this right. Yeah. So, people are sometimes suspicious of that. Actually, Amazon does sometimes let books go out early in special programs or stuff like that. But a lot of times, the early reviews are coming in from New Zealand because they got it just a few hours earlier than everybody else.
Gosh. Well, they read fast as well. Then
that's part of it. Is nobody believes it, and it's like, no, I love getting the new books, and I read them, and here's my review, and it's like, wow.
So it's not just New Zealand; it's bleeding edge Zealand.
That's right.
There you go.
Right. All right. So one of the things you just mentioned is that Undo has been an exhibitor at CPPCon almost since the beginning. We didn't have exhibitors the first year,
right?
But I think you've been an exhibitor every year since 2015, right? So how was the experience different this year? Now that we're in a new place?
Yeah, I mean, I guess there was. It's interesting that lots have changed, and then from if you look at it from a different angle, it hadn't changed, right?
Mm-hmm.
So obviously it was a very different place, different building, which did lead to a different feel, different size, right? I mean, certainly compared to the first one that we did. I mean, I think it's the conference is much bigger now, right? In terms of footfall. That makes a difference. I think you probably got a little bit more. I would think it certainly felt like pretty much everybody's traveled quite a significant distance to be there. So it felt like everybody was a bit more. Committed is probably not quite the right word, but you're in it, right? You're there now for the week or whatever, and you're
right.
You're in the whole thing, and there's no. Whereas when it was in Bellevue, a lot of people, obviously there's a lot of people in that area with Microsoft and Amazon and lots of other people being there. So a lot of people were kind of coming in for an afternoon or for a few hours and then going away again, and so there was, everyone was kind of fully into it, which I think made it. Which I think made it a nicer feel. It's more like going to a music festival than a series of concerts, if you know what I mean.
Right. Well, sometimes people, when I talk to people about CPPCon, when I'm not there, and trying to get people, hey, you should come to CPPCon. It's like, well, all the videos are online. It's like, well, tell you what, why don't you go to your boss and you say, I'm going to take a week. You don't have to pay for travel. You don't have to pay for a hotel. I'm just going to stay home for a week and watch CPPCon videos. And tell me how that works, because I don't think that's going to work, right? The fact that you're there, the fact that you've kind of made a deal with your boss and with your family to say, I'm going to spend a week to really immerse myself in C++, to catch up on all the stuff going on. And with the new standard every 3 years, there's a lot of stuff going on, right? Not only are we have the new features, but we're learning how to use them. And so that's
and you're immersing yourself in it in a way that you just can't do if you're watching videos and whatever. And I don't know, but I find it. I have a terrible attention span, so I find it really hard to watch a video and then not just to the end without kind of getting distracted by something.
Yeah.
And it's a mindset thing, right? And I mean, it's also like, you can say to a sports fan, well, why are you paying all that money to go to the game? You can watch it on TV, right? Or why are you going to the concert? You can just, stream it on and listen to the music. And actually the quality's probably better if you're listening to the CD or streaming it, right? The studio production quality rather than being live. But it's a totally different experience, right? And then, of course, what you also get at the conference is you get all the side conversations, right? So you just get those little chats in the hallway with people who maybe people well and don't see very often, or maybe it's someone who just met for the first time. You certainly don't get that when you're watching a video. So
and you also get the chance to talk to people who are there as exhibitors. You talk to people like Undo who are talking about tools. I mean, maybe you've been thinking about installing Coverity, but you don't know how much the setup time is, and you've heard about all these false positives. What do you do? Well, there's somebody there. Of course, we don't have Coverity as an exhibitor yet, but that may change. But you get the idea that the experts are there, and they're there to answer your questions. They're there to be engaged, and that's.
I think that's it. And so it's multifaceted, right? And then and this thing of just getting in that headspace for a week, right? Bill Gates used to go off for his Think Weeks when he was running Microsoft, right? And it's that if Bill Gates can go away for a week to do the Think Week, then I think most of us can learn from that and take a week where we're not fixing that bug or working on that particular sprint or going into those meetings that we all have to go into a lot. We're actually out and we're just thinking more deeply and learning, and just getting ourselves to be more productive for the years that come.
Right. Well, it can be a bit of stepping back a little bit. In other words, you're focused on your code and your bugs and exactly what your environment is without ever asking yourself, are we investing a lot of time and maybe doing it completely the wrong way? Just step back and ask that question. It doesn't mean you're going to scrap all your code and start all over, but you might step back and say, we've spent a lot of time trying to figure this out. Maybe there's a tool that does this, or maybe there's a library, or maybe there's a different approach that we could do that works better for us. And you're going to see all sorts of things at Cpp.chat. You're going to see people who are in different industries for whom the problem you're dealing with is their main problem. And how do they go about solving it?
Yeah. I mean, there's a reason why conferences are a thing, right? And it doesn't matter what, industry you're in, whether you're, a software developer or a surgeon or, and anything. People do conferences, people get together for, music festivals and whatever. There's just something that happens when you get, a few hundred people who are passionate and deeply passionate about the same topic to spend a week in the same hotel. Quite what the people who work in the hotel think of the event is another question, but
they've probably seen it all. We think, oh man, this is crazy, and they're like,
But the previous week was
So we are almost out of time. I wanted to talk to you about GDB Watchpoint, which sounds like a technical feature, but it's not a technical feature.
Right.
Actually, a series of videos. You want to talk to us about this?
Yeah. So it's kind of so the Watchpoint thing is a sort of pun on on the Watchpoint feature, of course. But yeah, so it's a series of videos actually inspired by the talks, some of the talks that I've given at previous years CPPCon, which has been about getting into some of the stuff that GDB does that most people don't know, right? So I think a lot of people have used GDB over the years, maybe kind of dipped their toe in the water, and they know, but it's like it's break, continue, next, print, quit. And those are the sort of set of commands that they know to use, and particularly
which gives you a lot of functionality just right there. There's a lot there,
right? But it's actually over the last, particularly over the last 5 years or so, GDB has grown a lot, right? From sort of full Python integration through to all kinds of advanced stuff for aimed not specifically at C++, but very helpful for C++, of kind of you sort of multiple breakpoints on different sort of template instantiations and catching exceptions and catching, you can sort of set catch points, which are like breakpoints, but when exceptions are thrown and when they're caught, and all kinds of stuff has gone in, and there's stuff that can really make you way more productive, just as a regular GDB user. So there's nothing is promotional. There's no undo stuff in there at all. It's just like the GDB that kind of ships with your distro. Here's what you can do with it. But rather than like the hour-long talks that I do at CPPCon or other conferences, these are kind of 5 to 10 minute little sort of bite-size segments, just going deep on a certain feature, and we do them. It's a sort of semi-regular kind of schedule of like every sort of once or twice a month kind of frequency. Just put out a new one. Often they're by me, but sometimes by guest speakers as well, just like we did at the last CPPCon. I find that works well. So we had one a little while ago on Emacs integration. You can use GDB from within Emacs as a kind of IDE type environment. I'm a proud VI guy, so I don't know how that stuff works. So
best to pass that one off.
Well, some of my good friends are Emacs users, so I'd ask one of them to do that session, and it's really it's been very popular, as I was sort of hoping it would, but we get a lot of views where I was even proud to tell my son how many tens of thousands of views this little thing had because he follows all these YouTubers. And he thought it was rubbish because all the YouTubers he follows have like 8 squillion subscribers or whatever. But I was happy with that.
Yeah. So it's a little bit like Jason's C++ series. It's bite-sized chunks. In other words, you don't have to sit down and say, I'm going to watch this for the next hour. You're not making a big commitment. You're committing to learn one little bit. So
you can binge watch them if you want, right? But I'm not sure but the kind of the idea is just a little bit, or I need to know about this now. But they're kind of they're intended just to I've got 10 minutes. I'm just going to watch this and just learn something useful, right?
Okay.
Small but useful.
Say you didn't have a long attention span.
Yeah, well, this is it. Yeah.
So you said you're a VI user, but in your CPPCon talk, I believe you actually use C-Line.
Yes. Yeah. So and of course you can use C-Line in VI mode as well, right? So the two are not exclusive.
We actually have a bit of integration.
Yes. Yeah, absolutely. So there's a plugin for undo in C-Line, and upcoming in IntelliJ as well. So we've got the Java. I know this is C++ stuff, but we've got the Java version just going into alpha just about now, and so we've got a plugin that works in IntelliJ and in C-Line, and just presents you with exactly what you would want. There's some backwards equivalents of the buttons to step back and into and out of function and stuff. So you get all that kind of and obviously debugging from and it's all and C-Line is talking to GDB underneath, or when we're running it thinks it's GDB, but actually it's undo DB. But yeah, so you've got all that. So from within C-Line, you can do all the fancy GDB stuff that in the screencasts by just dropping down to the GDB console.
Yeah. And if you do want to find out more about that, we did a webinar together. It was a few years ago now, so it's a little bit dated, but I'll put a link to that.
Was it a few years ago? Wow.
3 years, yeah.
Wow. That makes me feel old.
Oh, tell me all about it.
I'll go back in time.
Yeah.
So I just put up a link in the show notes for undo.io/resources/GDB watchpoint. Is that the best entry point for?
Yeah, that's it. Yeah.
Right.
Thank you.
All right. No, thank you. This is a great resource, and I really want to see more tool content at CPPCon and also C++ Now. I'm surprised at how little tool content is offered to us, and I feel the same way you do, which is that people underinvest their time in tools. I mean, it's great to read about some new C++ feature because that's going to get some payoff too. But tools is less sexy, but really pragmatic.
Yeah, exactly. And it's and look, to be the best, be top of your game, you've got to invest the time in both. You've got to know what the language is doing and how it's evolving, and what the latest, and the libraries and everything else that you can use, and you've got to be able to get the most out of the tools, and otherwise you're just going to be operating. If you don't do all of those things, you're going to be operating well below your capacity.
Right. One of the tools we didn't even talk about was Compiler Explorer, but there's these things that are online, these online tools for doing these kinds of things that are like, you got to spend the time to learn about this, because it's so easy to do things that used to be kind of tedious and
right.
problematic. So.
So a lot of them are just, a lot of these things are about, it's about getting into a kind of flow state, right? So things like Compiler Explorer, and I think probably GitHub as well is another example of this. Is it's just you can whether you're reviewing code or exploring what the compiler does, if you've got convenient tools that might look. A cynic might say that they're kind of just a bit of syntactic sugar on, or kind of presentational stuff on something. Well, I could do this just by typing into my terminal, right? It's like, you can, but you can't get into that kind of flow state, and you didn't. Yeah, exactly.
Yeah. So we've made it as easy as possible. So thanks for joining us, Greg. It's been great.
Yeah, no, thanks for having me.
And we end the show by wishing all our viewers safe coding. So if you'll join Phil and I, we'll say to everyone, safe coding.
Safe coding.